next question is state Clay-Hamilton theorem and verify for the matrix A where the matrix is 1 0 0 0 minus 1 1 and 2 1 0. So first state the Clay-Hamilton theorem. State. What is the statement? It states that every square matrix satisfies its own characteristic equation. This is the statement. Now we verify the characteristic. First we verify the characteristic equation. What is characteristic equation? Now characteristic equation is A minus lambda I equal to 0. In that case, A minus lambda I is 1 minus lambda 0 2 0 minus 1 minus lambda 1 0 1 0 minus lambda equal to 0. And we simplify that and we get 1 minus lambda square plus lambda minus 1 equal to 0. This implies that lambda cube minus 2 lambda plus 1 equal to 0. And this equation is satisfied by A. This equation is to be satisfied by A, then must be A cube minus 2A plus I equal to 0, where I is 3 cross 3 matrix. Now A square equal to 1 0 0 0 minus 1 1 2 1 0 and 1 0 0 0 minus 1 1 2 1 0, and simplify that we can easily find that 1 0 0 2 2 minus 1 2 minus 1 1. And for A cube is represented as A square into A, and what is the value of A square? A square is this. A square is 1 0 0 2 2 minus 1 2 minus 1 1 and 1 0 0 0 minus 1 1 2 1 0. And after multiplying that we can easily get that the value 1 0 0 0 minus 3 2 and 4 2 minus 1. Now satisfying the characteristic equation, this is 1 A cube minus 2A plus I, this is equal to 1 0 0 0 minus 3 2 4 2 minus 1 minus 2 into A. What is the A? Value of A is 1 0 0, which is given that 0 minus 1 1 2 1 0. And what is the I? I is a 3 cross 3 identity matrix 1 0 0 0 1 0 0 0 1. And we can simply solve it, and we can easily find that this is the 0 0 0 0 0 0 0 0 0. And hence the characteristic equation is satisfied by the given matrix A. Proved.